option A is correct. To avoid aliasing, reduce the bandwidth, cut out the high frequency, reduce the bandwidth and cut out high frequency. None of the above. So here, to avoid the aliasing, so Fs should be greater than 2Fm. So here it reduces the bandwidth and also the high frequency components are cut off. Therefore option C is correct. Which device is needed for the reconstruction of signal? Low pass filter, equalizer, low pass filter and equalizer, none of the mentioned. So in order to reconstruct the original signal back, low pass filter is used. So normally in ideal sampling and natural sampling, low pass filters are used, whereas in flat top sampling, equalizer is used. So to reconstruct the original signal back, low pass filter and equalizers may be used. 14th question is, original signal came to be retraced from sample version using. So that means reconstruct the original signal. Reconstruct the original signal from the sampled signal. So this can be achieved by means of, as from our previous discussions, a low pass filtering is used. So option A is correct. And 15th one is, a band-limited signal is sampled at the Nyquist rate. The signal can be recovered by passing the samples through an RC filter, an envelope detector, a PLL, an ideal low-pass filter with the appropriate bandwidth. So, a band-limited signal is sampled at the Nyquist rate, that is Fs should be greater than or equals to 2Fm, and to recover the original signal back, we have to use the low-pass filter with appropriate bandwidth. So, with appropriate bandwidth. Therefore, option B is correct. And the Nyquist sampling interval for the signal sync 700T plus sync 500T is. So the signal is given by sync 700T plus sync 500T, where this sync function can be written as sine 700 pi t by sine 700 pi t plus sine 500 pi t by 500 pi t. So from these two terms, we have to select the maximum frequency component. So from the first component, the frequency component is Fm is 350 Hertz because it is 2 into F into pi into T. So Fm is equals to 350 from the first term. And for the second term, Fm2 is 250 Hertz. So we need to select the one which is maximum because sampling theorem states that Fs should be greater than or equals to 2Fm, where Fm is the maximum frequency of the message signal. So Fm is equals to 350 Hertz. Therefore, the Nyquist rate is Fs is equals to 2Fm. So which is equals to 2 into 350 Hertz, which is 700 Hertz. But here for the signal, the Nyquist sampling interval. So in the question, it was mentioned that we have to calculate the sampling interval. So it is not sampling rate. If it is sampling rate, 700 Hertz. But we have to find the sampling interval, which is equals to 1 by Fs, that is 1 by 700 seconds. So option C is correct. And this is the 17th question. So the Nyquist sampling rate for the signal S of t is equals to sine 500 pi t by pi t multiplied by sine 700 pi t by pi t. So this can be written as two terms, two sinusoidal product of two sinusoidal terms can be represented by 2 sine can be represented by cos a minus b minus cos a plus b. So from these two terms, the highest frequency component Fm is from the second term, which is 600 Hertz. Therefore, Nyquist sampling rate is twice that of the maximum frequency, that is 1200 Hertz. And yesterday we have discussed about one small technique to directly find out the sampling rate for a signal in which two sinusoidal functions are multiplied or two sinc functions are multiplied. Or if the power of the first function is m and the power of second function is n, the Nyquist sampling rate is equals to m f1 plus n f2. So here the powers are 1. Therefore 1 into 500 plus 1 into 700, which is equals to 1200 Hertz. So the Nyquist sampling rate is 1200 Hertz. So we can use the simple techniques to solve the problems. So while dealing with these problems, so first verify that whether that function comprises with a product of two sinusoidal or sinc functions, or addition or subtraction of two sinusoidal functions, or convolution of two different functions. So based on that one, so we can select the method.